Hi, this is Moser with a quick tutorial on compositional stoichiometry, otherwise known as mole math conversions. By the end of this video, you should be able to perform any conversion between moles, grams, or atoms of any pure substance. That's it. That's pretty short. You should already know what a mole is and how many pieces are in one mole. You should know how and where to find molar mass and how to use the factor label method. As long as you've got those things, we're ready to go. So we very often, we see problems that say things like 246 grams of iron equals how many atoms of iron? Huh? We can find this number. We can actually find the individual number of atoms, which I think is kind of amazing, through the magic of stoichiometry. It's not just fun to do, it's fun to say. So what we're doing is compositional stoichiometry. Stoichiometry is a mathematical examination of masses and relationships of chemical substances. And what we're doing is just how much stuff there is. Pretty simple problems. To convert between something like grams to moles, or grams to atoms, or moles to grams, or moles to atoms, we have to remember that all conversions are based on a simple principle of multiplying by 1. So we multiply by stacks of things that are the same. So since 12.01 grams of carbon is equal to 1 mole of carbon is equal to 6.022 times 10 to the 23rd atoms of carbon, that allows us to multiply, just for example, some number of moles of carbon by our conversion factor, which is really just 1, which is 12.01 grams of carbon equals 1 mole of carbon. Because those two things are equal, we're just multiplying by 1, and that gets us some number of grams of carbon. So let's go ahead and start practicing these. The first thing that you need to know is that you have to remember your GMA. Aww, GMA. Well, in this case, it's not your grandma. It's grams, moles, and atoms. And when you're doing compositional stoichiometry conversions, this is going to be a helpful visual mnemonic that will remind you what steps you need to take to get from one unit to another. The other thing you're going to need is a periodic table. You can download this one if you Google search vanbrainerperiodictable.com, or I'll stick it on the plan. Okay, so we're asked here if we have 246 grams of iron, how many moles of iron is that? Well, when we look at this GMA mnemonic, we can see that to go from grams to moles is going to be a one-step conversion. And you know how to use a factor label method to do a conversion. You've done this with metric measurements. So what always goes in our first box are given. Now, if we're setting up a factor label, we're going to put our units, and in this case, our chemical in first. What has to happen down and across? Units and chemical have to match so that they'll cancel. So we know that the bottom here is going to have grams of iron, and we want to end up in moles of iron. Therefore, the next box is going to have moles of iron. When we cancel all of our units and chemicals, we'll end up in moles of iron, which is exactly where we want to be. Now, we've got our units and our chemicals all squared away, but where do we get the values that go into this problem? Well, the first thing that you should know is that you never put any number except 1 in front of moles unless your given is in moles. When moles are a conversion factor, we're always talking about 1 mole. And the number of grams of anything in 1 mole is, do you remember what that's called? Oh yeah, it's molar mass. That's right. And we get the molar mass from the periodic table. So 1 mole of iron atoms has a mass of 55.85 grams of iron. And actually, we should probably go ahead and use all of the digits that the periodic table gives us. So we'll make that 55.845 grams of iron. Okay, well, now you know what to do. So I've set up the multiplication across the top, multiplication across the bottom, dividing top and bottom. I have 246 times 1 divided by 55.845. What are my units? Well, grams of iron cancels grams of iron. We're left with moles of iron. And our raw answer is? Our raw answer is 4.4150, on and on and on, moles of iron. How many sig figs can we have in our answer? Well, that's determined by our given, which had 3. So our final answer is 4.42 moles of iron. Okay, so we've done grams to moles. Now let's do moles to grams. What if we're told that we have 4.7 moles of iron and we'd like to know how many grams that's going to weigh? We start with what in our first box? As always, our given, 4.7 moles of iron. I know that units in chemical here have to match so that they'll cancel. And I know that I want to end up in grams of iron. So I want to make sure that the units in chemical in the final box of my factor label are grams of iron. Now, before I can do something stupid, I'm going to stick a 1 in front of moles, because remember, unless moles is your given, as it is here, the only thing you should ever be putting in front of moles is the number 1. Now, how many grams of iron are in 1 mole of iron? Well, didn't we just look that up? We did! 55.845. We multiply across the top, divide by, well, 1. That's not all that exciting. Cancel out our units. Moles of iron cancels moles of iron. We're left with grams of iron. And we have a raw answer of 262.4715 grams of iron. Now, how many sig figs are we allowed here? Aha! We have to go back to our given, 4.7, which only has 2 sig figs, so our final answer is 260 grams of iron. Now, notice that we went from moles to grams. We didn't have to take any other steps. It's a one-step process. Let's try a slightly more interesting one. This is still a one-step, but for some reason these seem to be a little bit more challenging for people. So let's say we're told that we have 7.3 moles of aluminum, and we'd like to know how many individual aluminum atoms that would be. Well, if we look at the GMA graphic, we can see that this will be a one-step conversion, and we know we're starting in moles, so we're going to go straight to atoms. What goes in the first box of our factor label always? Our given, and we know that units in chemical have to cancel there, and that the last box of our factor label should contain the units and the chemical that we want our answer to be in. Now, the trickier bit, what numbers go in here? Well, I'm obviously going to stick a 1 in front of moles, because there's nothing that I should ever be putting in front of moles except the number 1, unless moles is a given, as it is in this problem. The harder part is how many atoms of aluminum are in 1 mole of aluminum. Well, let's go back to our initial slide. The molar mass of any element is equal to 1 mole of that element is equal to 6.022 times 10 to the 23rd atoms of that element. There's the number we're going to use for our conversion. So I have this set up nicely, 7.3 moles of aluminum times 6.022 times 10 to the 23rd atoms of aluminum per mole. Let's check my units. Yes, moles of aluminum cancel, leaving me in atoms of aluminum. Now the math. Well, I've multiplied across the top and divided by the bottom. But remember, because of this whole thing has to be times 10 to the 23rd. Let's get a raw number. I hate these. 43.9609 or 06 times 10 to the 23rd atoms of aluminum. You know what this means? We have to move the decimal. So I'm going to do my silly little bumps over, bumps back. What that tells me is that this is going to become 4.39, etc., times 10 to the 24th. I've got it in correct scientific notation, but am I done? Of course I'm not done. I still have to sig fig this. So how many sig figs can I have? We go back to our original given, 7.3, meaning we can have 2 sig figs, keeping that digit and rounding based on this. Our final answer, 4.4 times 10 to the 24th atoms of aluminum. Well, what if we want to go from atoms to moles? Again, it's a one step, as we can see by looking at the GMA graphic, and it's not all that complicated. But some people freak out over, well, the whole number of atoms thing. At any rate, what goes in our first box? Always, always, always? Our given! Yay! Units in chemical, down in the next box to cancel. atoms of aluminum, units and chemical in the final box of our factor label so that we end up in moles of aluminum. Moles of aluminum! So I'm going to stick that 1 in front of moles of aluminum before I do anything stupid. And how many atoms are in 1 mole of anything? I've set up my math. 1.5 times 1 divided by 6.002022 times 10 to the 23 minus 23. Oh, our exponents are going to go away. All right, let's get a raw answer. I get 0.2490 blah, 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 moles of times 10 to the 0, which is 1, moles of aluminum. And how many sig figs do I get? Aha, 2. So I'm going to keep this digit and round based on the digit that follows. The final answer is 0.25 moles of aluminum. Okay, so those are all your one-steppers, and they're not that complicated. You can see that you can go directly from atoms to moles, or moles to atoms, from grams to moles, or moles to grams, based on the GMA graphic. You know that your units and chemical have to cancel, and that your final box has to be the thing you want to end up in. So let's complicate things. Let's do some two-steppers. If I'm told that I've got 417 grams of copper, and I want to know how many atoms of copper that is, well, I'm going to have to go from grams to moles, and then from moles to atoms. This is a two-step conversion. But before you panic about anything, what goes in the first box of your factor label always and forever? Of course, you're given! Yay! What units and chemical go down there in the next box so that they'll cancel? Grams of copper, of course. And this might not be obvious, but if you're looking at the GMA graphic, you realize that you have to go through moles. So we're going to convert from grams to moles, putting moles of copper on the top in the middle, and then what units and chemical will go down here so that we cancel? Well, that's easy. It's got to be moles of copper. What do we want to end up in? Atoms of copper. So I'm going to do a few of those, stick a number in here before I do something stupid, and I'm going to put ones in front of moles every place that it appears unless it's a given. Now, there's really only one number that's going to ever appear in front of atoms unless it's a given, and that is 6.022 times 10 to the 23rd. This just leaves us one box to fill in. How many grams of copper in 1 mole of copper? We need our periodic table. Ha! I see you, copper. Get it? See you, copper. Anyway, this shows that there are 63.546 grams of copper in 1 mole of copper. Okay, now that I have all of my numbers plugged in, I'm going to check to make sure that my units cancel. Grams of copper cancels grams of copper. Moles of copper cancels moles of copper. I will end up in atoms of copper, which is right where I want to be. So I'm going to set up my math. Okay, I've got 417 times 1 times 6.022 divided by 63.546 times 1, the whole mess, don't forget your scientific notation, times 10 to the 23rd. Raw answer is, see that this one is going to make me move the decimal place yet again. So I'm imagining, well, I would go this way to get it down to times 10 to the 0, boop, boop, boop. So coming back this way, I'm going to make it times 10 to the 24th. Okay, I'm not done. How many sig figs can I have? Well, based on my given, I can have 3, which means I'm going to keep this digit and round it based on the one that follows it. I have a final answer of 3.95 times 10 to the 24th atoms of copper. That wasn't so bad, was it? One more. What if I have 923 times 10 to the 23rd atoms of silver, and I'd like to know how many grams of silver that is? Well, obviously this is going to be a two-stepper because I'm starting with atoms. I have to go to moles before I can follow the rest of the way through and take it to grams. What number goes in the first box of my factor label? Of course you knew that. My given! What units and what chemical are going to go down here so that they cancel? And though I know that I want to end up in grams, remember, I have to go through moles. So I know that this center box is going to have moles of silver, which means what units and what chemical will have to go here so they cancel, and what units and what chemical will end up in my final box so that I end up in those units and that chemical? Of course, grams of silver. So I'm going to do my real quick don't do something stupid Moser and stick ones in front of moles because the only number that should ever go in front of moles in a conversion is 1, unless it's your given. Right. Now, how many atoms of silver in 1 mole of silver? There's also only one number that can go there. 6.0022 times 10 to the 23rd atoms of silver. Whoops, I wrote atoms twice. Now, the only remaining mystery is what number goes in front of grams of silver, and where would I get that information? Aha! Periodic table to the rescue. Okay, I see that silver has a molar mass of 107.862 grams per mole. Honestly, we're going to take that to 2 digits after the decimal, so we'll make that 107.87. Okay, I have all of my numbers in place. I'm going to check to make sure my units cancel as I want them to. Atoms of silver cancels atoms of silver, moles of silver cancels moles of silver. I end up in grams of silver, and I have ones in front of moles, 6.022 times 10 to the 23rd in front of atoms, and the molar mass of silver. Excellent. Let's do this. Okay, I have my math set up. 9.23 times 1 times 107.87 divided by 6.022 times 10 to the 23 minus 23, which means that just goes away. Raw answer is 165.333792, etc., grams of silver. Now, how many sig figs can I have? Well, we have to go back to our given, which gives us 3 sig figs, meaning I'm just going to keep that and round it based on what comes after. Final answer is 165 grams of silver. Excellent. So, thing to keep in mind, the mole is always the heart of the problem. Aww. Meaning, anytime that you're going to do a 2-step conversion, atoms to grams or grams to atoms, you have to go through moles. They really are the heart of stoichiometry. Aww. Okay. Practice.